Download this code from codegive.com, link in the description below. Broken pipe error in Python, a comprehensive tutorial, Geeks4Geeks style. The broken pipe error, typically represented by broken pipe error in Python, signifies a sudden and unexpected termination of a connection between two processes communicating over a pipe, socket, or similar channel. This tutorial dives deep into understanding this error, its causes, and effective strategies for handling it within your Python applications. Understanding pipes and communication. Before delving into the error itself, it's crucial to understand the underlying mechanisms. Pipes are unidirectional communication channels established between processes, or threads. Data is written to one end, the write end, and read from the other, the read end. Sockets extend this concept to network communication. When one end of the pipe unexpectedly closes while the other is still attempting to write or read, a broken pipe error, or its oserror counterpart with errno 32, arises. This often happens due to circumstances beyond your immediate control. Common causes of broken pipe error. Several scenarios can trigger this error. 1. Premature client closure *. The most frequent cause is the client, the process reading data, terminating abruptly before the server, writing data, finishes transmitting. This leaves the server attempting to write to a closed connection. 2. Network disruptions *. Network issues, such as temporary outages or lost packets, can interrupt communication. If the writing process doesn't detect the disruption promptly, a broken pipe error will occur when it attempts to send data. 3. Resource exhaustion *. If the reading process runs out of resources, memory, CPU, it might unexpectedly exit, leaving the writing process unaware. 4. Signal handling *. An external signal, example SIGINT, SIGTERM, can abruptly terminate the reading process, leading to the error. 5. Process crashes *. If either the writing or reading process crashes, due to bugs or other issues, the connection is severed, causing the broken pipe error. Illustrative example, client-server scenario. Let's consider a simple client-server example using sockets to demonstrate how broken pipe error can manifest. In this example, the client deliberately closes the connection prematurely. This triggers a broken pipe error on the server side because it attempts to send data after the client has disconnected. Running this code will demonstrate the error handling mechanism in action. Effective error handling strategies. Handling broken pipe error effectively is crucial for building robust applications. Here's a breakdown of best practices. 1. Try, except blocks *. Enclose socket operations, especially sendle and reqv, within try, except blocks to catch broken pipe errors specifically. 2. Graceful shutdown *. Implement mechanisms for graceful shutdown on both the client and server sides. This involves providing ways to cleanly close connections, allowing processes to finish writing or reading before termination. 3. Connection checks *. Before writing data, check the connection status using methods provided by the socket library. This can help prevent writing to a dead connection. 4. Non-blocking operations *. Utilize non-blocking I/O operations where appropriate. These allow checks for connection status before attempting to send/receive data, avoiding blocking indefinitely on a closed connection. 5. Keep alive mechanisms *. Employ keep alive messages to maintain connection liveness. These periodic messages help detect connection drops early. Beyond sockets, other contexts. Broken pipe error isn't limited to sockets. It can arise in any scenario where communication occurs through pipes or similar mechanisms, example sub-process communication. The error handling principles remain the same, anticipating potential disconnect ions and handling them gracefully. Conclusion. The broken pipe error is a common yet often avoidable issue in network and inter-process communication. By understanding its causes, implementing appropriate error handling, and adopting robust communication strategies, you can create more resilient and dependable Python applications. Remember to always handle exceptions gracefully to prevent unexpected application crashes. This tutorial has equipped you with the knowledge and tools to effectively manage broken pipe error in your Python projects.